Welcome. In this and the next session, we will do two examples where the information about the points, asymptotes, and sign charts is given. We have to draw a graph that fits this information. We don't need to do any calculations. Let's first just go through the given information and then translate it into a form which we are accustomed to use. The first set of information gives us points on the graph. Each value of the function is a point. So if f of -3 is 2, then -3, 2 is a point on the graph. Let's plot the points as we go along. So there is -3, 2. F of 0 is 1, so 0, 1. F of 1 is 0, that's the point 1, 0. F of 2 is -1, that's the point 2, -1. And the final point given is 3, 0. Then we are given a vertical asymptote and a horizontal asymptote. So the vertical asymptote is at -2, that's our x equals -2. And there's a horizontal asymptote y equals 1, marking both of them. Let's look at the sign chart information. We are given both numbers where f prime or f double prime is 0, as well as where f prime is positive and where f double prime is positive, so on. F prime is 0 at 0 and 2, which means those are critical points, and we have horizontal tangents at each of those points. Points with x-coordinates 0, 1, and 3 are potential points of inflection. We don't know absolutely that they are points of inflection. We have to check. The point -3, 2 doesn't appear in this list, so it's neither a critical point nor a point of inflection. So we can ignore that while doing sign charts of f prime and f double prime. So we'll have to take the remaining points, 0, 1, 2, -1, 1, 0, and 3, 0, as well as the vertical asymptote at -2 into account in the sign chart. So if we list them in order, we go from -infinity, we first come to this vertical asymptote at -2. So that's the interval -infinity to -2. Next important point is the critical point and potential point of inflection at 0, 1. So it's the interval from -2 to 0. And from there we go to the x equals 1, where it's another potential point of inflection. And then 1 to 2, where I have a critical point with a horizontal tangent. And then from 2 to 3, where there is another potential point of inflection. And 3 to infinity, there are no points of inflection, critical points or vertical asymptotes. So these are our intervals. Now let's put the signs of f prime and f double prime in this table. So we start with f prime. F prime is positive from -infinity to -2. That's the first interval. It's also positive from 2 to infinity. That is from 2 to 3 as well as from 3 to infinity. The last two intervals. F prime is negative from -2 to 2. So from -2 all the way to 2. So all those three intervals. What about f double prime? It's positive from -infinity to -2. From -2 to 0, that's this interval. And then from 1 to 3. So 1 to 3 is these two intervals, 1 to 2 and 2 to 3. F double prime is negative from 0 to 1 and 3 to infinity. Now let's translate this information into the graph. From -infinity to -2, f prime and f double prime are both positive. So the function is increasing and concave up. It must start close to this horizontal asymptote, go up through this point, end up close to this vertical asymptote, and it is concave up. So it must have a shape like this. The next segment, -2 to 0, it is this portion. The graph is decreasing but still concave up. It must start close to the vertical asymptote, come to this point where we have a horizontal tangent. Since I should be going down, I need to start near the top and then come down, turn so that I get a horizontal tangent at 0, 1. From 0 to 1, the graph is decreasing and concave down. And from 1 to 2, it's decreasing but concave up. So at 1, there's a point of inflection. At 2, there is a horizontal tangent. So we need to turn this graph. From 2 to 3, the graph is increasing and concave up. So it turns up. And the final segment, 3 to infinity, it's increasing, concave down. Also, because I have a horizontal asymptote, the graph should end close to this horizontal asymptote. So it should go up and end up close to this. So one important point to note here. Sometimes people think that a graph cannot cross its asymptotes. This is wrong. A graph of a function cannot cross its vertical asymptotes, but it can cross its non-vertical asymptotes. The reason why sometimes people get the wrong impression, for the simple kind of functions that you see in the textbooks, where the calculations are simple and don't require a lot of algebra to do, are the kind of functions that don't cross the non-vertical asymptotes. If you have functions with higher degrees, then you can have a function that crosses its non-vertical asymptotes. And in fact, in front of us, we have such an example. This graph crosses its horizontal asymptote at the point 0, 1, which is moreover a point of inflection. That doesn't have to be the case. Remember that a graph can cross its non-vertical asymptotes. If a graph does that and you fail to indicate the crossing, I will dock you points. Goodbye for now.